check our part C. All right, so if I'm looking at f of x, I'm thinking to myself, all right, this is x squared minus 1. So I'm going to do parentheses squared minus 1, because whatever I'm plugging into my parentheses is my h of x. All right, this is the first time we're using h of x, so let me find what that equation is, the 3x minus 4. And then again, when you have a binomial that's being raised to a power, we have to FOIL this. So don't distribute, FOIL. Okay, so when you FOIL those, 3x and 3x is 9x squared. What's the nice thing about this? It's the same thing on the inside and outside. So negative 12 and negative 12 is negative 24. Negative 4 and negative 4 is 16. And then you still have that minus 1 on the outside. Okay, so then 9x squared minus 24x plus 15 should be your final answer. Now, yeah? Now let's do the domain together. Okay, so you FOIL, you apply the minus 1 to the like term. All right, when you're talking about the domain, really this is your checklist. Is there a fraction? Do we have a fraction? No. Do we have an even root? Even root. No, there's no radical in there. Do we have a log? No. So then what is our domain? Yes. Now how do we write that in set builder notations? Yeah. X such that X is an element in the real number set. Yeah, remember? Yeah. Because it has to be set builder notation. Because that's what it's asking you to. This is like the professional way of doing it.
Who would that?
The math class. Yeah, there's certain rules. Just like in English, you know. We have a subject, we have a verb.
Yeah, but that's like real.
Also,
This is real.
Also, English is suited in that
No.
you can turn any noun into a verb with a triarch method.
All right, let's go to part D. So if you guys haven't tried to set that up, go ahead and set it up.
It doesn't make as much sense.
All words are arbitrary. And so long as the human size, really.
There's a lot of special notations, a lot of simplest forms. Okay, so, oh yeah, okay, and then final escape. Yeah.
I don't know. Weird thing. It's not like it's weird. Noises without words. Like, I want water. This is green.
Show us an example.
No, okay.
All right, focus up and lock in. Lock it in.
Why dedicates their time into this stuff?
Yeah, but somebody has to program it.
Yeah, we should have kept it that way. Not us.
Okay, so your h of g of x, start with your h of x, so 3x minus 4. Okay? So when you plug this in, and it's a fraction, you do have to remember your fraction rules. If it helps, you can put a 1 under the 3 to remember that the numerator, or the whole number, gets multiplied by the numerator. So on top, you have 3 times x. Did you guys remember that you have to multiply the whole number by the top only? Okay, and then once you simplify that, that's it. And then we're going to go through our checklist. So, do I have a fraction? Yep. If I have a fraction, all I have to do is take that denominator, set it equal to 0 to find my restriction. When you have a negative variable, it's easier to just add it over. Just make sure that you are thinking about the opposite process. So when you do your domain, it's x such that x cannot be 1. The domain is the same thing. All right, let's try E. I feel like you could do all of E. When you get to G and H, those are going to be a little bit different. Okay, so go ahead, try it on your own. If you're still having trouble with the plug-in, remember you start on the outside. So if it's H, and you see the 3x minus 4, okay, if you feel like you're not ready to do the substitution at the same time, you can always do this and then go back. Okay, you can always go back. Some of you might be feeling more confident now, and you might want to plug it in as you go, just like you would with a number. You can decide. All right, now when you simplify, if there's a number on the outside, you do have to distribute. So you should have 3x squared minus 3. This minus 4 is just at the end. Do not distribute to something that's outside of the parentheses. And then once you go through your checklist, if there's no fraction, no root, no log, it'll be all real numbers. Yay. And that's your domain. What's that? No, because there's subtraction.
A lot of codes are confused.
What if you're on that like people making you laugh? Because you're not.
You guys are acting a little out of pocket today, okay?
Why is someone getting kidnapped by people making up the math without a calculator?
I think she's being sarcastic.
I'm just saying.
All right. So, again, I want you to start thinking about, can you start plugging these in without the parentheses? If so, give it a try. But I do like the parentheses when you do something where you have 1 minus a quantity, because when you have that minus, this is just an extra way to make sure that you distribute, whereas if you didn't have the parentheses, you might only apply the negative to the 3x and not to the 4. So just something to be mindful of. Okay, so when you do negative 3x, this becomes plus 4. So 1 plus 4 is 5. Again, there are 2 ways to write this. So if you wrote it like this, that's fine. That might be how it's written when you check your answers. Or you can write it in standard form. So either one of these are fine. Okay, and then there is a fraction, so we do have to make sure we set the denominator equal to 0. And so I did 5 minus 3x cannot be 0. I added the 3x over and then divided by 3. So x such that x cannot be 5 thirds. Yeah, so the last two have to do with k of x. Okay? K of x is the square root of x. So for the first one, k of x is on the outside. Because it's just the square root of x, when you plug this in, Okay, so when you have the k of x, it's the square root of, and then instead of x, we're going to plug in h of x. H of x is 3x minus 4. Now there's nothing you can simplify here. Your final answer is just going to be the square root of 3x minus 4. You cannot split this up, okay, and take the square root of 4 or negative 4. The only time you can simplify when you have radicals is if there's multiplication, which we don't have that. Now, we don't have a fraction, but we do have number 2 on the list, which is a radical. Okay? The main thing is when you have an even root, you can't take the square root of a negative. The way that we set this up is we take the radicand, which is the value underneath the radical, and we set it greater than or equal to 0. Again, it's equal to because if it's 0, that's fine. The square root of 0 is 0. You can calculate that. So the radicand is what's underneath. So underneath the radical is 3x minus 4. So we're going to set that greater than or equal to 0. And remember, with inequalities, it's similar process to equations. Divide both sides by 3. Okay, so x is greater than or equal to 4/3. So when you put that in your domain is all values of x such that x is greater than or equal to 4/3. Which means if x was not greater than or equal to that, you would not be able to get a real answer. For example, 0 doesn't fit into this. If I were to plug in 0, I'd get a negative. That would be a problem. All right, so part H is h of k of x. So again, we're going to be using the radical. So for h of x, we have 3x minus 4. We're going to plug k of x in for x, which is root x. The simplification on this is pretty quick. If you do 3 times root x, you get 3 root x, and then you just keep the minus 4. You can't simplify any further. That would be your final answer. Okay, now for the domain, it's the same thing, where you take the radicand and you set it greater than or equal to 0. So what is the value underneath the radical? Just x. So it's just x is greater than or equal to 0, and that's how you're going to put it in your domain. X such that x is greater than or equal to 0. Anytime you just have x underneath, that is what you will have. Okay, so your homework from 6.5, which I highly recommend you complete, okay, is numbers 2 through 13, 16 through 31. Okay, and again, that is something that you are turning into Google Classroom.